Hello everyone, I'm Big Cat. In the last lesson, we made the character movement feature. Run the game. We found that the character instantly went from 0 speed to 600 speed when we start moving and was also very blocky at max speed to freeze. We wanted to smooth the transition of the character's speed. Before we create a smooth increase in speed, let's add an input parameter. Add the variable named walk_speed. Tab float and category move. This parameter represents the content character's maximum move speed value. Set this value to control the character's maximum movement speed, which will vary when the character is in a different pose or state. Compile. To test the effect, set the default value to 600. Open Moving on the ground. Gradually add the maximum character movement speed before adding the character's movement speed. Get the character movement while my character. Then you can get the speed vector. And by getting the length of this vector, you can get the current character movement speed. Add phi to the current speed. This represents an increase of phi per frame. Determine if this speed is less than or equal to the maximum speed. If the maximum movement speed is not exceeded, set this value to character movement's maximum speed. To make the blueprint more readable, turn this part of the blueprint to nodes and name it Smooth Increase. Double-click to enter. Add the input parameter, named Execute. Tap EXEC. Connect to the branch. If the maximum movement speed exceeded, set the maximum speed for character movement to walk speed. Add the output parameter, named Zen. Tap EXEC. Connect to the output node. Return to moving on the ground. Connect the nodes. Run the game. Press the W key. The character already has a noticeable smooth acceleration effect. Compile, save. Next, make the speed smoothing reduction. Open my character. Select character movement. Check the Use Separate Braking Friction box. Checking this option will start the friction reduction for the character. Run the game. When the Move button is lifted, the character will have a noticeably smoother deceleration. Compile and save. That is for this lesson. Thanks for watching, and we'll see you next time. Hello everyone, I'm Big Cat. When the Alt key is pressed, move the mouse to rotate the viewport without affecting the character's current movement direction. In this lesson, we're going to create this feature. Let's start by changing a few default values. Open my character. Select the root component in my character. Find the Use Controller Rotation yaw in pawn and uncheck it. Later, we decide when to use the controller's rotation through our controls. Next, make the character follow the rotation of the mouse. Open my player controller. Create an event take event. This event will be triggered in every frame when running. Add the sequence node. Get the value of the controller's rotation. Add Set Actor Rotation node. Set at each frame. Here, we only need to set the Z value of the actor. Split the return value. Set the Z value. Compile, save. Run the game. The character follows the mouse rotation. Next, move the mouse to rotate the perspective without affecting the character direction when the Alt key is pressed. Get the Alt key event. Add a variable named Alt pressed of type Boolean category input, used to indicate whether the Alt key is currently pressed or not. When the Alt key is pressed, set Alt pressed to true. When the Alt key is released, set Alt pressed to false. It is necessary to record the camera's rotation value when the Alt key is pressed. Since the camera is hanging on the spring arm, we need to get the spring arm's rotation value when the Alt key is pressed. record the current rotation value. It is named Alt-pressed rotation. Category input. When the Alt key is released, record the current rotation value, named Alt released rotation. Category as input. These two variables will be used in many later calculations. Add a determination of whether the Alt key is currently pressed or not when synchronizing the rotation value. If the Alt key is not currently pressed, the rotation value will be synchronized. Add comment. Run the game. When the Alt key is pressed, move the mouse, and the viewport follows the mouse rotation, but the character doesn't not rotate. Set the Alt key pressed state to be false when the Alt key is released. Run the game. When the Alt key is released, the character rotates to the viewport position, but now rotates momentarily. We want the viewport to automatically return to the position it was in before the Alt key was pressed when the Alt key is released. Next, we will animate the shot by using a timeline. Create a timeline and name it TL Camera Restore. Connect it to play from start. Double-click to open the timeline. Set the length to 0.3. This means that the timeline will play for 0.3 seconds. Create a track of type float. Single right-click on the track to add a key point. Set the time of this key point to 0 and the value to 0. Add another key point. Set the time of this key point to 0.3 and the value to 1. Single these two buttons to see the full track. This timeline will be executed from this 0, 0 position to the 0.31 position. Right-click on the 0, 0 point and select User. This will allow us to adjust the curve. Adjust it to be first fast and then slow. Right-click on the stand-alone track name and select Rename. Name it Percentage. Go back to Event Graph. Every time the timeline animation plays, an update will be performed. We want to set the rotation value of the controller each time the update is performed. Get the lerp node of type rotation. In this node, A and B are the two rotation values. Alpha is the percentage value. If it is 0, then A is returned. If it is 1, then B is returned. Shortest path is very important. If checked, it means that the shortest path from A to B is selected. This variable needs to be checked. Set the value of A to out released rotation. Set the value of B to out pressed rotation. Set the percentage in the timeline to alpha. Set the return value. Change to see the Alt key press false again after the animation plays. Delete the node. Run the game. Hold down the Alt key to move the mouse, and release the mouse to restore animation. Add comment. Add comment. Compile. Save. That's it for this lesson. Thanks for watching, and we'll see you next time. Hello everyone, I'm Big Cat. In the last lesson, we made the ability to move the viewport freely by pressing the Alt key. However, there will be problems if the character is moving. Run the game. Move the character while holding down the Alt key. The direction the character moves will follow the direction the mouse moves, which is not what we want. We want the character to move in the same direction as before the Alt key was pressed. Open My Player Controller. Open Moving on the Ground. This is where we get the current controller's rotation value. Change this value to a parameter. Add an input parameter named controller rotation. Tap Rotator. Here change this to the input parameter. Compile and save. In response to the move event, add a determination of whether the current Alt key is pressed or not. To make the blueprint more readable, select Judgment, right-click, and choose Collapse to Function, named Get Controller Rotation. Go to Get Controller Rotation. Add the output variable. Name it Rotation. Tap Rotator. Select Pure. Add a local variable. Name it Return Rotation. Tap Rotator. This local variable is valid only within the current function, in the same way that we write code to define a variable within a function. If the Alt key has been pressed, the rotation before it was pressed is used. If the Alt key is not pressed, the rotation of the current controller is used. Finally, this rotation value is returned. Go back to Event Graph. Connect node and parameter. Run the game. Pressing the Alt key to move the mouse during a move doesn't not affect the character's original movement direction. Compile and save. That's it for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. The character has 4 poses on the ground. One is standing, one is crouching, one is prone, and one is jumping. In this lesson, we're going to make a switch between these 4 poses of the character. First, let's make the crouch switch function respond to the crouch keyboard event. Determine if currently prone. If it is prone, then set prone to false. And crouch to true. The character goes from prone to crouch. If it is not prone, determine if it is currently crouching. If it is crouching, set the crouch state to false. The character goes from crouching to standing. If not crouching, set the crouching pose to true. The character goes from standing to crouching. Run the game and press the C key to see that the character can go from standing to crouching position. Press the C key again to go from crouching to standing pose. Add the pawn to crouch comment. Add the crouch to stand comment. Add the stand to crouch comment. Add comment. Next, make the pawn switch function. Respond to the pawn keyboard event. Determine if the content position is pawn. If it is pawn, set pawn to false. The character goes from pawn to standing up. If the character is not pawn, determine if the character is crouching. If the character is crouching, set crouching to false. And pawn to true. The character goes from crouching to pawn. Here, you also need to set the aiming state to false. If the character switches to pawn, this process cannot be aiming. If the character is not crouching, it means the character is standing. Set pawn to true. The character goes from standing to pawn. Here, you also need to set the aiming state to false. If the character switches to pawn, this process cannot be aiming. Run the game and press C to see that the character can go from standing to pawn. Press C again to go from pawn to standing. Press C and then C. The character goes from a crouching to pawn. Press the C key to move the character from pawn to crouching. Add the prong to stand comment. Add the crouch to prong comment. Add the stand to prong comment. Add comment. Next, make the jump function. Respond to jump keyboard event. Determine if the current position is prong. If it is prong, set prong to false and crouching to true. The character goes from prong to crouching. Determine if the character is currently crouching. If it is crouching, set crouching to false. The character goes from crouching to standing. If the character is currently standing, then call drop. Run the game, press the space bar, and the character jumps. Press the space bar will change to crouching. Then press the space bar again to change to standing. Add the prong to crouch comment. Add the crouch to stand comment. Add the jump comment. Add comment. Compile and save. That's it for this lesson. Thanks for watching and we'll see you next time. Hello everyone, I'm Big Cat. In the last lesson, we made the character pause a switching feature. The character cannot move when switching to the prong. When it comes to the pause, switching related to the prong position. When the prong position's translation animation is playing, the character cannot move. The disallowed time is the transition animation playtime. We keep track of this time by creating a date table in the blueprint folder. Create a new folder named Datas. All static data will be placed in this folder. Create a new folder in the Datas folder, named Data Table. This folder holds all the data table files. Create a new folder in the Datas folder, named Table Structure. This folder holds all the structure files that are needed for the data table. Create a structure in the Table Structure folder and name it st_time. Open. We only need one variable for this table. Name it sec and type it float. It indicates the number of seconds needed for the transition animation. Save close. Create a data table in the data table folder. Select st_time. Name it dt_time. Open. Add a row of data. Row name is set to false, prone, crouch. False means unarmed. Prone means currently prone. And crouch means target position is crouch. Friend the animation of the transition from prone to crouch for unarmed. The duration of the animation is 1.267 seconds. Go back to the data table and set the unarmed transition seconds from prone to crouch to 1.267 seconds. Add a row of data. Row name is true prone crouch. It means the gun state from prone to crouch transition animation. Here, you can open the animation and see the number of seconds according to the mouse just described. Later, in order to save time, I've checked the number of seconds of all the animations in advance so that I won't open them one by one. Set the number of seconds to 1.567. Add a row of data. Row name is set to false prone stand. Set the number of seconds to 1.4 indicates the animation of the transition from prone to stand unarmed. Add a row of data. Row name is set to true prone stand. Set the number of seconds to 2.667. Indicates an animation of the gun state transition from prone to standing. Add a row of data. Row name is set to false crouch prone. Set the number of seconds to 0.967. Indicates an animation of transition from crouching to prone in the unarmed state. Add a row of data. Row name is set to true crouch prone. Set the number of seconds to 1.467. Indicates a crouch to prone transition animation for the armed state. Add a row of data. Row name is set to false stand prone. Set the number of seconds to 1.167. Indicates an animation of the transition from standing to prone in the unarmed state. Add a row of data. Row name is set to true stand prong. Set the number of seconds to 2.333. Indicates that the gun state is animated from stand to prong. We have now configured all the animation times for the prong transition. Save, close. Open my player controller. Add a variable. Name enable move. Type Boolean. Category action. This is used to indicate if the current character is movable or not. By default, the character can be moved, so you need to set the default value to true. Find the response to move the event area. Determine if the character is currently movable before moving it. Create a macro named hold position. This is used to prohibit the character from moving for a certain period of time. This macro does not need to have a written parameter. Add input parameter named execute of type exec. This will create an execution node. Add an input parameter named isHoldWeapon of type Boolean. Indicates if the gun is currently held. Add an input parameter named current of type string. Indicates the current pulse. Add an input parameter named target of type string. Indicates the target pulse. Get the get date table row node and set the date table to dt prong time. Append the string by the input parameter. Split the return value. Set disable mode. Call the delay node. After the delay is complete, allow the move. Return to event graph. Call the macro when switching a prong-related pause. Find the crouch key event response area. Halt when prone to crouch. Find the prone key event response area. Halt when prone to standing. Halt when crouching to prone. Halt when standing to prone. Run the game so that all transmission animations associated with the prong do not move the character while playing. Compile and save. That is for this lesson. Thanks for watching, and we'll see you next time.